Okay, I presented this talk, Scalable Data Approximate Analysis of National Water Model Data in the Cloud, at the NOAA Environmental Data Managers meeting in April 2018. And I mentioned in the talk that you could do the same kind of workflow that I did in this talk on the cloud, that you could do that same workflow on high performance computing. So I'm going to show the same workflow that I showed in the talk, but done on HPC. And this is all thanks to the Pangeo project. The Pangeo project has these really nice setup guides for getting this sort of data approximate scalable computing going on HPC and on the cloud. Here's the HPC instructions, here's the cloud instructions. So I basically followed these instructions, and I'm just going to show you it actually working. So I'm going to be using this USGS Yeti cloud. So the first thing is you have to make sure that you're on the TIC. So I'm on the Trusted Internet Connection here, and that means I should be able to open a terminal window to Yeti. So I'm going to log in here. I'm SSH in. Okay, so I'm in, and the first thing I want to do is actually start a interactive session. So I can never remember the syntax for that, so hopefully I've got one around somewhere. Let's see here. Okay, so here's one. S allocate in the normal queue, Woods Hole, one process for 3 hours. Okay, so let's execute that. 801, oops, 801. Okay, so it says pending, waiting for resources. And hopefully it'll come back in just a second and say, I've got the resources. So from here then, we're going to actually start a Jupyter notebook. Okay, so I'm in here on this login, and I've got a little script here, in fact, that says it's called Start Jupyter. So let's take a look at that. And basically, what this is gonna do, just a very short script here, and it's going to just print out an SSH command that I'm going to use. Oh, sorry. First, it activates a Pangeo conda environment, which has all the Python stuff that I need, and then and I'm going to it's going to echo this SSH command, and then it's going to start the Jupyter Lab server with no browser, and it's going to start it on this specific port here. So I'm actually just going to run this script then. Start jupyter.sh, and it prints out that command. So then I can just grab that. Okay, yep, and copy it. And I'm going to open up another. Actually, I can just do it right here. Well, I'll leave that window open actually in case we need it. So because I want to show you something there. So I'm going to switch over to this other terminal, and we're going to drop that command in there. All right, so here's the SSH command. So I have to log in again. And so now I should be able to go to this port 8877 in localhost and see 8877. Okay, if I go to that, I should see Jupyter Lab. Okay, so this is Jupyter Lab running on Yeti. I actually kind of like the old notebook. I'm not really used to the Jupyter Lab yet, so I can go type tree and get back to the old style Jupyter notebook that may look more familiar to you if you've been using Jupyter for a while. So there's a bunch of different notebooks here, but I want to show you this National Water Model notebook. So I've got this notebook read Xarray. And the first thing I'm going to do is I'm just going to clear all the output. Okay, so restart the kernel and clear all the output. So basically in this, I'm just going to step through this. I'm going to load some Xarray, which is we're going to use to load the data. I'm going to load dask-distributed, which does the parallel processing. I've got a little string here defining what kind of environment I'm on. So if I'm on this environment, Pangeo Yeti, I'm actually going to Let's make this a little bigger. I'm going to point to a specific file here that I'm going to load on Yeti. I'm going to use this Slurm cluster from dask-jobqueue to actually kick off to use a Slurm to submit a job, or actually multiple jobs that have Dask workers that I can connect to. So Dask is the distributed processing system. It's going to kick off these workers. And so here's some stuff about the jobs that it's going to kick off. And actually here I'm going to say start 2 of these workers. Okay, and it's going to print out the job script. So if I go ahead and submit this, you can see this command here actually ends up submitting a job that looks like this. And so so this is just for another system, so that's not gonna do anything. So now I have this cluster, hopefully, and if we go to, actually, let's see, let's bring up our other window here and do sqr signal. We should be able to see, now we can see these 2 jobs that we submitted, they're running, okay? So they were pending, and now they should be running. So if we go back over here, yes, we see we have 8 workers. So we have 4 workers on each of those 2 jobs that we submitted. Okay, so we have this client then that we can use, and we have a dashboard. We can see how much memory we have, and then we have this dashboard, which we can open on localhost. Actually, if we go back and look, we see we want to go to the local. We want to go to port 8878 to see the status. 8878. Okay, so here is 8878, and this. So here's this dashboard, and we can see our workers here. Each row of these, if I go down, you can see each one of these is a different worker. Each row on here. So now we go back here and let's open up some data. So we're reading from this Xarray format, which I've translated the data from NetCDF into Xarray, which is actually a nice format for locally, but it also works really well on the cloud. And so here's my data set that I loaded in. You can see these different data variables like rain rate and temperature, the temperature at 2 meters off the ground. Let's read in temperature. So let's take a look at the temperature variable. We can see that it's 23 gigabytes here. And this command is just going to take the mean over time. But if I click it, you see it comes back immediately because Dask does not do anything until it actually needs the data. So I haven't really requested I needed the data. I just said here, do the mean, and it showed me what it's going to look like. But if I actually want, unless I plot it or do some evaluation with the numbers, it's actually not going to load the data. So this next line where we say persist, it actually is going to load the data, and we're going to take the mean over the time dimension, and then we're going to watch the progress there. So if I enter this cell, you can see it start to work, and here are these different jobs running. Now if I go over to the dashboard, we should be able to see the different workers working, and here they are. So these different workers are working away. Down at the bottom you can see these jobs progressing, and if you hover over here it says what these things are doing, like this is loading data from Xarray, and this is computing a mean chunk. And so you can see that the workers are actually keeping pretty busy. So those 8 workers, Dask is doing a good job of scheduling the workout to those workers. If we saw a lot of white space in here, we would be concerned that it wasn't doing a good job. So if we go back here, we can see that that finished. So we made use of all those different processors, and now let's just plot up the data to see what the mean looks like, confirm that we've got something here, and there's the US. You can see Florida down there, California over here. And now if we take a slice through time, we can go give me everything along the time dimension at a particular grid cell, 2000, 2000. Just want to show you this to show you how fast it is, because here it just reads one chunk of data, so it comes back almost immediately and gives you a time series. And if we want to stop the workers, we can stop them like so. Let's just go back and see. We can see our jobs running here. That the Dask workers that this submitted, and they're running. And if we go here, we can say cluster stop workers, and we should see those jobs disappear. Yep, and they're gone. So that's it, and thanks.